Welcome to the deep dive. Today we're getting into something really fundamental, the evolution of the agriculture industry. And look, this isn't just some dry history lesson. We're mapping out a journey that, well, basically shaped human civilization, population, our whole modern economy. Our sources track this massive transformation, from the earliest tools in the first villages right up to the super efficient, data-heavy farms we see today. Our mission, pretty simple. Pull out the key bits of knowledge that help you understand why this long history is actually crucial for tackling today's big issues, like food security and, of course, climate change.
Exactly. And when we look at agriculture's history, yeah, you see this constant technological push. But what's really interesting, I think, are the shifts in thinking behind the tech, that constant drive for more efficiency and now resilience. So we've sort of boiled this down for you, the curious listener, showing how ingenuity solved problems of scale in the past and, how those lessons might just apply now.
Okay, great. Let's start unpacking that right at the very beginning, the Neolithic Revolution. This was that massive turning point, wasn't it? Happened in different places, independently, where people stopped roaming and started farming, settling down. And the real genius then wasn't just figuring out how to plant stuff. It was the result, the surplus food. Domesticating plants, animals, making simple tools like hoes, early plows. Suddenly, not everyone needed to be out finding food.
Right.
That surplus, it fueled population growth, let people specialize. I mean, that's the foundation for basically every complex society, right?
It absolutely is. And what you have to remember is settling down also meant huge new risks. If the crops failed, you couldn't just pack up and leave. So that pressure, that necessity, it drove early societies, think ancient Egypt, Mesopotamia, to become incredible engineers. They came up with sophisticated irrigation systems. Game changer. Bringing water reliably to dry areas, taking some of that risk out of relying on, fickle rainfall.
And that drive to optimize, it kept going, didn't it? Though maybe pretty slowly for a long time. After that initial revolution, we see these gradual improvements. Like the Romans had quite sophisticated crop rotation methods. And later, in medieval Europe, you get things like the heavy plow, the three-field system.
Yeah, the three-field system is a neat example. Instead of planting one field and letting one rest, losing half your land use each year, you switch to three. Rotate crops, only rest a third. Bang. Better yield per acre, keeps the soil healthier longer. But even with these clever ideas, farming was still just incredibly hard work. All muscle power, really, not much science involved yet.
Right. Until things started to speed up. Quite dramatically, actually, with the scientific revolution, the Enlightenment.
Exactly.
That whole mindset of systematic observation, experimentation, it started to filter down to the farm.
People had been doing selective breeding sort of informally for ages, right? Picking the best seeds, the strongest animal. But now it became deliberate, scientific,
right,
leading to better crop varieties, maybe more disease resistance, that kind of thing.
Okay, so that brings us to what you might call the real inflection point, the agricultural revolution. 18th, 19th centuries, happening right alongside the Industrial Revolution. Suddenly, productivity just soared, thanks to some key inventions, both mechanical and chemical.
Yeah, the seed drill Jethro Tull's invention, that's a fantastic little piece of innovation to focus on for a second.
Okay.
Before that, farmers mostly broadcast seed, literally just tossing it out there. Super wasteful, uneven growth.
Right, I can picture that.
The seed drill, totally different. Puts seeds in neat rows at just the right depth. It sounds simple, but it's a profound shift. It's moving from, guesswork to precise engineering. You could almost say it's the conceptual ancestor of today's precision farming.
That's a great way to put it. And while the tools got smarter, the understanding of the soil itself was being completely changed, particularly by Justus von Liebig.
Liebig, yes. He's the guy who really brought chemistry to the farm, you could say. Killed off the old dirt under the fingernails guesswork in a scientific sense. He figured out the chemistry of soil nutrients, N, P, K, nitrogen, phosphorus, potassium, what plants really needed.
Okay.
And that understanding led directly to artificial fertilizers.
Yeah.
Suddenly, farmers could put back exactly what the crops took out, boosting yields way beyond what nature alone could manage.
So you've got this new chemical understanding plus the new power source from the Industrial Revolution that sets the stage for the 20th century, right? The age of mechanization.
Oh, absolutely. The internal combustion engine. That changed everything. Tractors, combines, replacing animals, replacing human labor on a massive industrial scale.
And the economic impact must have been enormous.
Unbelievable. Huge increases in speed, efficiency. One farmer could now manage vastly more land which of course led to a dramatic drop in the number of people working in agriculture, certainly in developed countries. And it fueled the rise of large-scale commercial farming, chasing those economies of scale.
Okay, so mechanization changed who farmed and how fast. Then comes the Green Revolution, which changed what was farmed and how much yield you got. This period, roughly, 1940s to 1970s, probably the single biggest agricultural shakeup of the 20th century.
Arguably. Yeah.
Led by scientists like Norman Borlaug, right?
Mm.
The focus was developing these high-yielding varieties, HYVs, of staple crops, wheat, rice especially.
Mm-hmm.
These new plants, combined with modern inputs, fertilizers, pesticides, better irrigation, the yield increases were just spectacular, especially in Asia, Latin America. It's credited, quite rightly, with saving maybe billions from starvation, a fundamental shift in global food security.
It absolutely did achieve incredible things in terms of sheer volume, but, and this is a really important but, we need to look at the costs. That success came with significant environmental and social price tags that, frankly, we're still dealing with today.
How so?
Well, Borlaug's HYVs, for example, were often shorter plants. They put more energy into the grain, less into the stalk, so they wouldn't fall over from the weight of all that extra grain.
Makes sense.
But they were demanding crops. They needed lots of those artificial fertilizers Liebig's work had enabled. They needed reliable water, often meaning massive irrigation. And they were typically grown as monocultures, needing pesticides.
Ah, okay. So intensive.
Very intensive. And that led to problems. Soil degradation from chemical overuse, water pollution from fertilizer runoff, a big loss of biodiversity as landscapes turned into single crop fields. Plus, all that irrigation put huge stress on water resources. And economically, the need for expensive seeds and chemicals sometimes widened the gap between large landowners who could afford it all and smaller farmers who couldn't.
Right. So the Green Revolution solved the immediate problem of quantity, but it kind of created this environmental debt, didn't it?
That's a good way to think about it. And that realization, that lesson learned, directly influenced the next major shift: biotechnology and genetic engineering, starting in the later 20th century.
Okay, so moving beyond just broad chemical application, the idea here was to be more surgical.
Yeah.
Directly manipulating plant genes to build in desirable traits, things like natural pest resistance or tolerance to herbicides, maybe even boosting nutritional value.
Exactly. Aiming for crops that need fewer external inputs because the advantages are built right in. Now, genetically modified organisms, GMOs, they're still pretty contentious. Our sources certainly show the debates about safety, environmental impact, ethics. They're definitely ongoing. We're not taking sides here, just reporting.
Understood.
But looking at it purely as a tool, biotechnology is incredibly powerful. It allows for much faster development of crops that are resilient, maybe crops that can grow in tougher conditions or address specific dietary needs, especially relevant now with climate change ramping up.
And resilience really feels like the key word for the 21st century, doesn't it? We've moved into the era of precision agriculture or smart farming, this convergence of IT, sensors, automation. We're now optimizing things down to, like, the square meter of a field.
It's all about data. GPS is foundational. Farmers map fields with incredible accuracy.
So instead of just spraying fertilizer evenly over a huge area.
Right. You use variable rate application. Satellite imagery, soil sensors, yield maps from previous years, all that data tells the machinery to put fertilizer or water or seeds only where they're needed and in the exact amount needed for that specific spot.
Huge savings on inputs, less environmental runoff, better profitability. Makes sense.
And the sensors doing the monitoring are key. Soil moisture, nutrient levels, temperature, constantly feeding data back. What's really cool is the aerial view. Drones with multispectral cameras. They can spot crop stress or disease before it's visible to the human eye just by changes in how the plants reflect light.
Wow. Invisible problems made visible.
Exactly. Allows for proactive intervention, not just reaction.
And I guess AI ties all this data together.
Precisely. Artificial intelligence, machine learning models, they crunch all this data historical performance, real-time sensor readings, weather forecasts to make predictions and automated decisions. The system might say, okay, based on everything, that section of Field 3 needs exactly 1.5 liters of nitrogen per hectare applied in 3 days to hit peak yield potential and minimize lodging risk.
And robotics carry out those instructions.
Increasingly, yes. We're seeing more than just giant self-driving tractors, though those are impressive. We're seeing automated guided vehicles, AGVs, smaller, specialized robots for tasks like planting, weeding, targeted spraying.
And even delicate jobs. I read about fruit-picking robots.
Yeah, that's a big area of development. It requires sophisticated computer vision, delicate manipulation, things that used to absolutely require human hands. That's changing fast.
And we should probably touch on the urban frontier, too. Vertical farming, controlled environment, agriculture, CEA.
Good point. These systems often indoors, using hydroponics or aeroponics, LED lighting, climate control. They essentially decouple food production from traditional farmland and weather
This
patterns.
is useful in cities or places with harsh climates.
Exactly, often using a tiny fraction of the water needed for field crops. It's another piece of the puzzle.
Okay, so all this amazing tech, it's really being driven by this final massive challenge, sustainability and resilience right now.
Absolutely. That's the core pressure now. Global population heading towards, what, nearly 10 billion by 2050?
Yeah.
We need more food produced with fewer resources, less water, less land, ideally and crucially, with a much smaller environmental footprint. And looming over all of it is climate change. Extreme weather, shifting rainfall, heat stress. It's already hitting crop yields and livestock pretty hard around the world. That's the new reality farmers have to factor in.
That pressure is pushing the industry towards solutions that, interestingly, sometimes blend high-tech data with older ecological principles.
That's right.
We're seeing things like conservation agriculture gaining ground, methods like minimizing soil disturbance.
No-till or minimal-till farming, yeah, hugely important. Tilling breaks up soil structure, releases stored carbon, harms the soil microbes. Keeping the soil covered, disturbing it less, it protects it.
And things like permanent soil cover, diversifying crops instead of monocultures.
Mm-hmm. And agroecology, too, applying ecological ideas directly to farming systems, encouraging biodiversity, using natural predators for pest control, integrating trees and crops.
And organic farming continues to grow, appealing to consumers wary of synthetic inputs.
Water, though. Water seems like the really acute pressure point. Agriculture uses such a massive chunk of the world's fresh water.
It's huge, yeah. Scarcity is a major, major challenge.
So the strategies have to be broad. Definitely wider adoption of efficient irrigation, like drip systems that put water right at the roots. Developing crops that are just naturally more water efficient through conventional breeding or biotech. And this is critical tackling food waste. So much water, energy, and land use is embedded in food that just gets thrown away.
That brings us nicely to regenerative agriculture. This feels like more than just a set of practices. It seems like a shift in philosophy.
I think that's fair. It's not just about doing less harm. It's about actively improving the ecosystem.
Practices like cover cropping, planting things specifically to protect and enrich the soil between cash crops, combined with no-till.
They actively build soil health.
Right. They increase organic matter, improve the soil's ability to soak up and hold water, sequester carbon. It's about creating a more robust, resilient system that can better handle those climate shocks we talked about.
So looking back, it's been quite a journey we've traced. It really has. From, simple plows driven by sheer necessity and muscle to these incredibly complex, data-driven AI systems.
Yeah.
All chasing efficiency and now increasingly resilience.
The big takeaway for you, listening, is that agriculture has always been this mirror reflecting humanity's progress. It built our world. But the focus, it's decisively shifted. It's not just about maximizing output anymore, is it? It's this complex balancing act, productivity and environmental responsibility.
Which leaves us with a pretty critical question, I think, something for you to really mull over. Given these immense pressures, climate change, population growth, the shift needed isn't just technological. Moving from conventional farming to more resilient models like regenerative ag or agroecology, it requires a fundamental change in philosophy, in how we see our relationship with the land. So the question is, how fast can that philosophical shift alongside the practical changes actually scale up globally, fast enough to securely feed the next 10 billion people on a changing planet?
An essential question indeed for perhaps our most essential industry. We hope this deep dive gave you some food for thought about the sources and the ongoing evolution of the land that feeds us all. Thanks for joining us.